You are welcome once again in this tutorial. So as I discussed with you in my previous videos, most of the time it is often necessary to rewrite expressions involving sines, cosines, and tangents in their alternative forms. So to do this, trigonometric identities are being used as I explained previously. Compound angles, as we are about to discuss, can be either sum or difference, and from which we can get double angles from if it happens to the fact that the two angles are equal. And these double angles are equally important, and it is mostly used in most of the engineering fields. At most instances, compound angles are required, for example, in the analysis of most acoustic, or where beat is an interference between two sounds of slightly different frequencies, and with phase detectors as well. We have so many places that we can use these ones to help in simplifying expressions into their alternative forms, which makes them easier to analyze. Let's look at calculus, for instance. When you are being given sine to the power 5 theta, you can use these expressions to simplify some part of the question in order to be able to solve them. Without these identities, unless you use calculator, it will be very difficult for you to simplify them into their various simple forms. So now, without wasting much time, let's go straight and look at the various compound angles that we have here. So the first one that I was talking about, we are going to consider 4 of them here. We are going to consider the sine. Let me use a different print so that you can see it clearly. The first one I'm going to consider is the sine into bracket a plus b, assuming that a and b are our angles under consideration. The second one we are going to also consider is sine a minus b, and then the next one that we are going to consider is cos a plus b, and obviously the next one is cos a minus b. The sine a plus b is going to give us sine a cos b plus cos a sine b. The sine a minus b is going to give us sine a cos b minus cos a sine b. The next one that we have to do is cos a plus b, which is also equal to cos a cos b minus sine a sine b. And then the last one is cos a cos b plus sine a sine b. These are the 4 main compound angles that I want us to look at. Of course, we have the tan a plus b, the tan a plus b, which is equal to tan a plus tan b over 1 minus tan a tan b, and also tan a minus b is also equal to tan a minus tan b all over 1 plus tan a tan b. But because these 4 main ones are the ones from experience that are being used most at times in the field of engineering and other courses as well, we are going to look at them into details, and if possible we will talk something small about the tan a plus b and then the tan a minus b. So now let's go straight to see what we can do with these compound angles or trigonometric identities. We have so many identities that we can generate from these 4 trigonometric identities. So looking at this, maybe you may meet an example whereby you need to simplify the expression by using these kind of trigonometric identities. For instance, maybe you have seen a question whereby you have been asked to do something in calculus or integrate, and they have been using sine maybe a cos b. How do you do this integration? Of course, this is simple to do, simple integration that you can do. But let's assume that you know nothing about it, but you have these trigonometric identities at your disposal. What can you do to be able to simplify this expression, to be able to make it clear for you to solve? To do this, it is necessary that you combine these trigonometric identities to help you come out with a simpler one. So looking at the first and then the second identity, when we add these two identities, which is sine A plus B and sine A minus B. The first one is sine A cos B minus or plus cos A sine B. And this one is sine A cos B minus cos A sine B. When I add these two identities, this one, because it's negative, is going to go out with this one, and I'm going to get 2 sine A cos B to be equal to sine A plus B multiplying by or plus sine A minus B. So this is for 2 sine A cos B, but if we have only sine A cos B, we can have an identity as 1 over 2 multiplied by sine A plus B plus sine A minus B. So this is one trigonometric identity, very important identity that you need to keep in mind. So when I have any expression like this, of which I have been asked to integrate or differentiate, which is of course simple to do without using this identity, and I want to use the identity, I can take note of the angles, whatever is inside, and then write it in this form. And you can testify that when you are being given this trigonometric question in this form to differentiate or integrate, you can see that this is easy to do. So this is one key identity that you need to keep in mind, and you need to keep it in your toolbox wherever you go as you sail forward in your academic journey. Let's look at the reverse. The first one, we added these two identities. What if we subtract it? We subtract one from the other. So when we subtract one from the other, we are going to get, let's say, sine A plus B minus sine A minus B. It's also going to give us, because we are subtracting this one from the upper one, this part becomes negative, and therefore this one goes away. So now we will be left with this part. So if we are being left with that part, we are going to also get 2 cos A sine B. And of course, the same approach, we are going to get cos A sine B is equal to 1 over 2 into bracket sine A plus B minus sine A minus B. And knowing this one, when we are being given any sort of this one, either in your calculus class, in your engineering courses class, in your financial engineering courses class, in any of the classes that you are taking, whenever you encounter this, you can use this trigonometric identity to simplify them to a solvable form, or the form in which you will be able to solve easily without even using calculator. So now let's look at the other side of it. We have another two. We can do same for this. When we add the third and the fourth one, we can also get cos A plus B plus cos A minus B. Because we have added them, we are going to get, because here is negative and here is positive, it also goes out. And now we are going to get 2 cos A cos B. It's got 2 cos A cos B. And therefore, as we have done earlier on, we can get cos A cos B to be equal to 1 over 2 into bracket cos A plus B plus cos A minus B. This is also another identity that you must keep in mind. So assuming that we are subtracting them, When you subtract these two identities, we are also going to get cos A plus B minus cos A minus B. We are going to get 2 sine A cos B. Because when you do that, this one becomes rather the negative, and here the negative will cancel out. We are going to have this part, and at the end of the day, we are going to get sine A sine B. Yeah. So sine A, let's write here, sine A sine B. It's also going to give us 1/2 cos A plus B minus cos A minus B. So this is the results that we are going to get when we combine these identities that we have written up here. When we combine them, we are going to end up with these results. So let's kindly take note of it. So these are the 4 very important trigonometric ratios after combining all these 4 identities. But let's look at something here. This is in terms of which I have been given the question in terms of cos. This one. So if I know this identity of head, I don't have to know this, because I know that when they give me the one in terms of sine, the only thing that I need to change is the sign in between them. You can see here it's positive and here is what? Negative. So that's one thing, crucial thing that we have to take note of it. So I think based on this tutorial, you have been able to understand how I was able to combine these identities to come up with the various essential trigonometric identities that is useful in various courses that you are doing. So in my next tutorial, we are going to talk about the situation whereby A is equal to B. That is, the 2 angles are the same. And for that matter, we are going to talk about double angles. Thank you for watching, and see you in my next tutorial.